So this presentation is going to cover basic drafting in CAD. So some people may know or not know, but CAD stands for Computer Aided Design. So Autodesk, there's an entire family of it, and they put out a whole slew of products, several of which are listed here. We're really only going to talk about two in this class, and it's mainly just going to be the general all-purpose design, the top bullet point there. You will have to summarize a presentation on Civil 3D from a previous student. For that one, it kind of gives you more stuff in the civil engineering field, like pipe networks, and it's easier to incorporate like surveying data, stuff like that. But each one of these has like different features based on what it's going to be used for. So I would assume the architectural one will have a lot more materials that are associated with architecture. But for this class, the whole goal is to get you a solid foundation in just general Autodesk and AutoCAD, so you could build on that with whatever you end up having to use. So, AutoCAD. This slide is briefly to touch on some of the features in AutoCAD. So, parametric drawing, I'm assuming you guys still did the bottle rockets, or I think you may have done wind turbines at some point, where you did parametric design, where you essentially hold everything constant except for one thing you're looking at. So like this angle or this ratio of wings, stuff like that, or mass of clay, whatever. AutoCAD could do something similar to that, where it just holds certain stuff constant and varies the other. Different sheet sets you could set up, dynamic blocks, so those are just blocks, so you could draw something once and keep inserting it in. You'll kind of use that for your floor plan assignment. Additive scaling I'll probably cover in another video at some point, but essentially what happens there is when you go to your title block and you scale it, say you have a small object and it's just a 1-to-1 ratio, but you may have like a large site plan and you need something that's 1 inch is equal to a mile. Those are two drastically different scales. So in the olden days, you would have to manually change the text height to get it to view a certain text size on the title block. What annotative scaling will do is it'll take the viewport scale and it'll automatically calculate it to what you want. So if you want your text height to be 1/4 of an inch or 1/8 of an inch when it's printed, it does that calculation for you. Your final project will be a 3D house. These next few slides are just going to show you some of the ones that have been created before. This was one that I created in like 15 to 20 hours over spring break, the first year of teaching it, because I was getting a lot of questions. It's like, hey, what do you expect? It's like, expect something along these lines. But you'll see some of my students put in more effort than I did just over that first spring break. Here goes somebody else's design, another design. So you may be scared about like, how am I ever going to end up drawing this? But all these people, they got there as well. Civil 3D, like I said, is built on the same platform as AutoCAD. It has many additional features that aren't in regular generic AutoCAD. Like I said, stuff for contour and surface maps and like pipe networks and stuff like that. But you'll be able to watch that one presentation and summarize and see how it's different than your base AutoCAD. All your drawings, unless otherwise specified, must include a title block. So a title block is essentially used to display additional information about the drawing. So like who drew it, if there's any revisions, the scale, the date, etc. After we go over this presentation, well, actually I already sent you the title block, so it's already made for you. You just have to know how to utilize it. But failure to include any of the information on your title block will result in deduction of points. So it's just stupid points to lose, so make sure you fill it out. These are the steps on how to actually load in your title block into CAD. So if you look towards the bottom left, you'll have layout. This is an older version of CAD, probably like 2016, but it'll be the same thing essentially. You'll right click on layout and you'll click from template, and you'll find that file I gave you. I think it's just called title block, the one I created. You'll push OK, and then if you look down towards the bottom, instead of layout 1 and layout 2, there will be a new tab that opens up that is the title block, and this is where you could get whatever you drew in your model space to show up, and then put in all the information, the name, the date, the assignment, sheet, scale, so on and so forth. So there are a whole bunch of different types of maps that you could use while making CAD. Here are some of the more common ones. So engineering maps, they include stuff like property lines and boundaries, existing, proposed. I'm not going to read all of them. You could read all of them if you want, but they generally include those types of things. So here's an example of like a site plan type deal. This is specifically, if you look on the bottom right, for Central Street, East Bridgewater, Massachusetts. So it's just giving you a good amount of detail. When you become engineers, you'll start to see stuff that's more complex like this. Here's a more dumbed down version. Aeronautical and nautical. So this type of map is of a region to show certain terrain or other hydrographic features to provide information for air navigation of maritime areas and neighboring coastal regions. I've personally never dealt with something like this, but I just want you to know that it's something that's out there. Cadastral, which are cities or towns. Your assignment is like one on the right. Oh, apparently it was AutoCAD 2014. Even older than I expected. Son of a... All right. Each one of these individual, like lots of lands, are called plats. But this is a cadastral map, and they show lot lines and boundaries that are just drawn to scale. Quadrangle, they feature land divided into sections. Never dealt with it, but again, it's out there. Topographic, this is your contour map type stuff. So each contour line will correlate to a specific elevation. It could show you when there's summits or streams and stuff like that, and what the elevation and how steep of a drop off there is. Geologic and hydrologic, this shows the distribution of geologic features, so stuff like rocks and faults. They could also show stuff such as rivers and streams. Photogrammetric and remote sensing. So this is all about focus on obtaining information about distant objects and processes from sensors that are not in contact with the objects. And then there's further analysis of the acquired data. I don't really deal with this too much either. And a digital elevation model, which is essentially a 3D representation of a terrain surface. So it's like a 3D contour map. This is a treasure map that I created. So more map and drawing elements. So in order to convey more information on maps and other drawings, you may have to use different lines, line types, line weights, notes, different text, stuff like that. So here's just showing different types of line types, symbols, things like that could be included in your drawing. This slide is here to just give you a brief note on notes. So there's two different types of notes. There's general notes and there's specific notes. So specific notes are something that would apply to a specific thing of this object. So these are generally denoted by leaders, which are those little lines with the little note on top of it. So it's pointing to a specific aspect of this drawing, and it's telling you what it is. So the cultured stone only applies to that portion. General notes, which if you look at the bottom, it says all dimensions are in inches, that applies to the entire drawing. It's not just one specific aspect of it. This is a website if you want to deal with CAD standards. So if you really feel like nerding out, I'm not really going to go over it because whatever employer you have is likely just going to have a certain way to present your drawings. So, like if you work for the NJDOT, they're going to end up using MicroStation, and they're going to want their files in a certain way with certain line types and certain line weights, certain text sizes. My employer wants something different. It's much more closely related to this, where there's just a national CAD standard out there. But throughout my work, I've learned that whoever your client is going to say what they want, and you're going to do it because you want to get paid. And that's how it is. So I don't go into too much detail about this, but just know that it is out there, and if you really want to nerd out, you could. Layers. I recommend using lots of them. So these could be things like walls, doors, windows, text, dimensions, furniture, blah, 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 blah. You could literally break down anything you want into a different type of layer, and it's just an easier way of organizing your drawing. If you look at that middle picture, like if you're dealing with an electrician, he may only want to deal with certain things, like here's the walls, here's where certain utilities are. Or if you're trying to see where electrical things are, you may just want to look at the electrical things, like here are the outlets, here are the where the lines run, so on and so forth. So you can turn off different layers as you need them to see your drawing. And it just helps to organize it and show the details and features that only you need to look at. Detailed drawings are larger scale drawings of smaller parts or structures or machines or whatever, and they are usually used to provide sufficient detail on something that you may not be able to see from a further out view. So it could say like, oh, this part right here is this type of screw, and it's at this angle, and it's set in this much, and so on and so forth. So that's what detailed drawings do. That's the end of this presentation. There will be a couple more, and then there will also be the ones that you have from student presentations at some point.